Okay, so this conversation is going to be a continuation of our lymphatic chapter. And when we introduced the lymphatic system last time, one of the big things that I wanted to point out, and I kind of want to cover it again very quickly, is that so many times when people talk about the lymphatic system, they immediately just refer to it as the immune system. And because there are other functions that the lymphatic system carries out, you want to stay away from that, because collecting fluid from the body tissues and delivering them to the cardiovascular system so that they can be cleaned out of the body, as well as making sure that the fats that you put into your system through the foods that you eat, that all of those are eventually making their way to your bloodstream so that you can utilize them or put them to use, are very important functions of the lymphatic system as well. So yes, immunity is a very huge part of what the lymphatic system does, and because of what an important part that is, we tend to gravitate towards that more in our lectures and our conversations. But don't forget that those other pieces are important as well. And when you refer to this system, to refer to it as the lymphatic system so that you encompass everything that it does, and we don't just isolate it to its role within immunity. So in Blackboard, I posted a new packet to go with this. I bumped up the one that was initially passed out at the beginning of the year, and so you'll see some things that look similar if you still have that original packet, but I added some things to it, so you can print that off if you have the ability to. If you can't print it off, you can open it up through Blackboard and follow along and just take notes on your own paper to kind of go with this. But when we talk about the immunity side of things, one of the biggest things to understand is the role of white blood cells within the lymphatic system. So you have two types of blood cells, red blood cells and white blood cells. Red blood cells are going to be devoted to making sure that oxygen is getting delivered to all of the cells of the body, as well as nutrition. So as you guys are digesting the materials that you put into your system, they make their way over to the bloodstream. That is going to be delivered to the cells so that they can then utilize it and build different cellular products. It's also going to collect any of the waste product that has been built in the cells. So any waste product that is contained inside the cell, that's going to be the job of your cardiovascular system to clean that out. Any of the waste product that makes its way out of the cell and is in the tissues surrounding the cells, that's going to be the job of the lymphatic system to clean out. So a little bit of a distinction there. But with those white blood cells, they have a much different role. They are really kind of the army of the body, and their job is to circulate through the system and identify anything that it doesn't recognize as being part of your body. So they are head to toe, they are constantly in your system, and they are bumping into other cells, tissue types, anything that they come in contact with. The first thing they're doing is identifying whether or not they can recognize it as being something that you actually made. So we have 5 different types of white blood cells, but I want to be very careful to also explain that you have a lot of different subcategories under those 5. So you kind of have the main 5 out there, and then underneath each one of those you could put several different types of white blood cells as well. So this is a very big topic, but for our purposes we're just going to kind of highlight those main 5 so that you get an idea of what they do. The reason that we have the different categories and so many different types of white blood cells is because it allows them to really specialize in what they're going to do within the body. And if you can specialize and pinpoint just one thing or one task that you have to do, you can get really, really good at that. And so it allows our immune system to be much more efficient in how it needs to work as it comes in contact with things that are getting into your system. So just a little bit of a recap on your immune response. And we talked about this a little bit in the integumentary system, but that was back in first semester. Not everybody was with us. But when we talked about cells and the integumentary system, we did cover some of this, so it might sound a little bit familiar. On the surface of the cells, you guys have different materials in the form of protein, and then you also have carbohydrate flags. These are pieces that extend off the surface of the cell, and they are what your body will use to recognize that this is something your body actually created. So if you think about when you use a flag to identify what country and what territory they've been to, that's essentially what we're doing with these carbohydrate flags or these proteins, is we are marking that cell as being something that was produced internally. Anything that gets into our system, any type of foreign invader, is going to have its own carbohydrate flag, but because we didn't make it, your body's not going to be able to recognize it. If you think of a particular language that you don't speak, if you had to try and read that off of a sheet of paper, obviously you're not going to be able to recognize that. It would be foreign to you. And so it's the same type of thing with our cells. If you go to the cell-to-cell recognition, the reason that we need to have cell-to-cell recognition internally is because as you guys grow and develop, you want your organs to be able to grow as well so that they can take care of all the needs of your body. If your heart was still the same size today that it was the day you were born, obviously that's not going to be able to support what your body needs today. So your organs do need to grow and develop, but it needs to be in proportion to your growth. And so to make sure that those organs are growing the right size, they are going to use that cell-to-cell recognition. So when the body grows and gives them more space, they will grow as well. But when those carbohydrate flags from neighboring organs bump into each other again, that lets them know that they've taken up all the space that's available and they need to shut down that growth. We talked a little bit about autoimmune diseases and just that your body will lose the ability to recognize its own cells, and that is going to be a result in an autoimmune. So anytime that stops happening, your body will start attacking those cells because it now considers them to be foreign, and you will destroy those cells within your body. Some of the common invaders that we have would fall into the category of being an antigen, pathogen, a bacteria, a virus, or cancer. Now, the one thing that I want to point out about antigens, and again, this is a recap from previous conversations, antigens they are particles that have the ability to trigger an immune response, but they don't necessarily have to. And that's why you have people that take it outside on a spring day, and some people are enjoying it, and other people are fighting the watery eyes, the runny nose, all of that, because those antigens, as they inhaled pollen and dust and whatever else was floating around in the air, the antigens on those materials triggered an immune response for them. In other people, the antigens didn't cause an immune response, and so they had no reaction to it whatsoever. So antigens can cause an immune response, but they don't have to. So they're not always going to cause problems within the body. Pathogens are always looking to invade their host. So they are always they're basically always going to cause problems if they're able to get into your body. Bacteria and viruses, I'm going to touch on these a little bit more later on, but those are probably two of the most common ones that we think of when we think of invaders getting into our system. And then the last one is cancer. And cancer is always present. When you think of having billions of cells within our body, to think that everyone is perfect and exactly the way it's supposed to, that's not the case. Everybody has cancer cells, but our immune system is so good at recognizing those cells that don't belong, it is able to get rid of them before they're ever able to grow and multiply and really cause any problems. But it is one of the common things that our immune system has to deal with. So here's the slide that talks about bacteria and viruses, and just to kind of distinguish between the two a little bit. When you talk about a bacteria are living. So they are cells. They have the ability to multiply and grow in number on their own, and they are also going to have some positive and negative features depending on what type of bacteria that you're dealing with. So there are some bacteria that their only goal is to get into a body and cause problems. But you also have bacteria that live in like our digestive tract, for example. And without those bacteria, we can't digest food. So obviously those are a very positive thing to have within our system. Probiotics are a huge thing right now, and probiotics are basically talking about creating an environment within your intestinal tract that is going to allow you to build up as many of these bacteria as possible. It makes digestion more efficient. You get more nutrition and value out of the things that you're putting into your body. On the other side of that, when you talk about a virus, you cannot ever talk about a virus and use the term cell. Viruses are not living, they cannot replicate on their own, and so they do not fall into the cell category. And this is another place where people will use the term incorrectly all the time, and they'll talk about a viral cell. You can't. Because if you had a bunch of bacteria sitting on a tabletop, they could increase in number sitting on their own. If you had viral material on a tabletop, however many were there, that's how many there would always be. They would have to have a person come in contact with them and then have that virus get into the body somehow. Once it has access to your cells, what it will actually do is it docks with your cell, it injects its genetic material into your cell, and then it uses the components inside your cell to kind of carry out its agenda. So now you're building viral material instead of building materials that you need for that cell or for your body. And so it basically takes over the cell. But it does have to have that host in order to be able to do that. The immune response. So when we talk about the immune response, once something has been identified as not belonging in your body, you are now going to put into motion a series of events that is going to identify that foreign particle, figure out how to deal with it, and then destroy it before it's allowed to replicate and really cause a lot of trouble. So we talked a little bit about the antigens and the pathogens already, and then the B cells and the T cells. This was introduced in our first lecture, but the B cells and the T cells fall into a category known as lymphocytes. And these are going to be the two main classes that are going to really help your body manage those foreign invaders and put your system into a place where you can learn about them before you completely destroy them. If our bodies just attacked everything right off the bat, then day in and day out, you would be constantly fighting the same battle from the ground up. But what your immune system does is it learns about these things before it attacks them and kills them, so that the next time you come in contact with it, you already know. Your body has a head start. It knows exactly what it is, it knows exactly how it works, and it knows how to destroy it, making you much more efficient. So that's why you can get a vaccination, your body gets introduced to it, and then anytime after that that you come in contact with, you already have those immunity cells built up to destroy that foreign invader, and so your body works at a much better rate, and you're much less likely to get sick from it. So this slide talks about the different types of white blood cells, and I wanted to put them in color, which was a little bit different from those first packets that I printed off at the beginning of the year because they were all black and white. But I wanted you guys to be able to see them and kind of have them side by side so that you can make some comparisons. The first thing that I want you to notice, and we will look at blood smears when we come back together at our next face-to-face meeting, but you can see the pinkish red cells hovering all around. Those are your red blood cells, which shouldn't surprise you that they would be present in a blood smear. When you look at this though, this doesn't really do it justice to represent the fact that your red blood cells should outnumber your white blood cells about 600 to 1. So if you were to see a much larger image of this, you would notice that your white blood cells are few and far between. They are larger than your red blood cells, and they usually are going to stain purple, which makes them easy to identify when you're looking at a blood smear, because you have all these pinks all over the place, and then randomly throughout the slide, you'll be able to focus or find these purple cells, and those are your white blood cells. So the 5 main categories that we have, you have the basophils, you have the eosinophils, you have the neutrophils, and then we have the monocytes, and we have the lymphocytes. And the next few slides just kind of cover those 5 categories, giving you some of the different characteristics and features of those different white blood cells that we have. Now, before we go too far into that conversation, I do want to designate between what are known as agranulocytes and granulocytes. So within those 5 classes of white blood cells, you have 2 different groups. You have what are known as the agranulocytes, which that prefix of just the letter A indicates without. So if you break that down, sites, or A is without, granule refers to grain, site means cell. So this is a cell that does not have grains. Then you have the granulocytes on the other side, grain cell. And what actually happens within these white blood cells is they have these tiny granules inside, and those granules are filled with a toxic material. So when they encounter a foreign invader, they have the ability to excrete these granules. Then they release that toxic material, it coats those foreign invaders, and it allows for them to be destroyed. It's kind of a mass production, so that if they are dealing with a high number of invaders, they can deal with them, a high number of them, in a very small period of time. Not all of your white blood cells have those. So your agranulocytes would be those white blood cells that lack or do not have those grains, or if they have them in very small numbers. Granulocytes have the grains, they have that as a backup method to use if they feel like they are that outnumbered by the foreign invader that they need to coat them with this toxic material. So looking at the first white blood cell that you guys have, basophils are going to be the least common type of white blood cell that you guys have within the body. If you look at the description, it talks about the fact that they do have those granules, so this would fall into the category of being a granulocyte. And while we know that those granulocytes have that toxic material and are able to coat and break down those foreign invaders, there is still research being done to figure out if there's any other capabilities that they have, why some of them have them and some of them don't, and things of that. So still in the learning phase of those granulocytes and exactly everything that those grains can potentially do for the cells. Looking at the major function, so your basophils are going to have two main products that they are able to release to perform their job. And so like I said, these cells are very specific to what they need to do so that they can be very good at it. So with your basophils, they are going to produce an anticoagulant, and so that anticoagulant is going to impact how your blood works, and then you also are going to have the ability to release histamine. So within the body, you are dealing with those allergic responses. So for those people that go outside and they get exposed to that pollen and they get the runny nose and all of that, that is going to be in part because of the basophils. So you have the anticoagulant, so heparin and histamine are going to be the two products that your basophils are going to be able to release in reaction to what's going on in and around your body. The eosinophils are going to be another group of white blood cells that we tend to have in a fairly small number within the bloodstream. If you look these up, or if you're looking in your book, it will tell you how many you have per microliter of blood. I'm not so worried that you guys know that. Those numbers are very, very specific, and to know each one, we really don't need to do that for our purposes quite yet. So when we look at the eosinophils, this is going to be another one that is going to contain those granules. And when you look at the cell itself, you can see those grains. So within the cytoplasm, you can see all of those dots. It looks very speckled, and that is the presence of those granulocytes within the cell itself. Now, surrounding the eosinophil here, you can see that you have the red blood cells. The eosinophil is very evident in the middle, a little bit darker red in the cytoplasm, and then the nucleus is a very definite purple. But if you notice, you have the smallest particle that you have on that slide, a little bit of purple. That's actually a platelet. So we talked about the fact that you have some cells, those megakaryocytes, which will break down and fragment and turn into these jagged edge pieces. That's actually a platelet that you're able to see there, and that's what that small piece is. So when we look at the job of the eosinophil is going to deal with parasites. Now, as unpleasant as it is, everybody has parasites. Depending on where you live in the world, some people are exposed more and have to fight that or deal with that more, but every single person has parasites. And so the eosinophils are going to be responsible for dealing with and reacting to those parasitic infections. This is also going to play a role in your allergic reactions and how severe your allergic response is. And again, that's why some people can eat peanut butter and they are just fine, and other people, that is potentially fatal if they come in contact with peanut-based foods. So that is going to be contributed to the eosinophil response and how severe the eosinophils respond to a particular antigen being introduced to the body. Now, when you look at the eosinophil, the other thing that I want you to do is pay attention to the nucleus. So the nucleus here is the purple section of that cell, and you can see it's bilobed. So it has two different parts to it, kind of looks like a horseshoe or a rainbow, but the presence of those granules as well as the bilobe shape of the nucleus would be things that you could use to identify this if you were looking at it underneath the microscope. If you go back to the basophil, basophil, again, you can see those granules and that speckling appearance, and it's just kind of spread all throughout. So very dispersed through the cell. Again, that purple is showing you exactly where the nucleus material is of the basophil, but very distinct in the fact that you have those grains and that it's dispersed throughout the entire cell. So I want you guys to recognize not only if it's a granule or granulocyte or an agranulocyte, but also pay attention to the nucleus, because that is going to be a huge factor in being able to distinguish these white blood cells from each other. So now if we move forward to the neutrophil. Neutrophil is going to be the most common type of white blood cell that you have in the body. You should have this in the largest number if you're comparing these 5 categories of white blood cells. So when you look at the neutrophil, one of the things that makes it identifiable is that it has a massive number of nuclei. So again, you see the purple here designating the nucleus, and you'll notice that there are many different sections to it. They're kind of all connected and interlinked, but you have several different lobes that make their way throughout the entire cell, and that's one of the key features of the neutrophil. You do have granules within the neutrophil as well, so that's an option that it has to use when it's dealing with foreign invaders, is being able to use that toxic material. If you look at the functions of the neutrophil, one of the things that it's actually going to do is it can basically grab onto the sides of the blood vessels and create a barrier. So if there is a foreign particle that has invaded the body, it will actually prevent them from being able to just easily pass through, kind of creates a net or a block. So for those things that are coming in, you cut yourself, fall down and get a scrape, whatever the case might be, those neutrophils are going to get to that spot very quickly, form a net, and kind of try to block those bacteria or viruses from being able to easily gain entry into the body through that wound. The other thing that your neutrophils will do is they are phagocytes, which means that they will eat anything that is foreign, and basically the neutrophil will find the foreign particle. It basically engulfs it, wraps itself around the foreign particle, pulls it to the inside, and then will break it down at that point, and they will just keep engulfing and ingesting these foreign cells as long as they can find them. The next one that we have is the lymphocyte. So with the lymphocytes, this is where your T cells and your B cells are going to, they're a subcategory of the lymphocytes. So lymphocytes, if you look at the particular cell there, and again, hopefully you can identify that off to the right in that picture, you have a couple of platelets that are showing up there. But the defining characteristic of a lymphocyte is that the nucleus, that purple section, you'll notice that it almost takes up the entire cell. So that is really the defining characteristic. It's usually round in nature, but it is going to take up a large majority. 90% of the cell is usually going to be the nucleus. And so that makes it very easy to distinguish. It's nice and round, almost the exact same size as the entire cell itself. So when we look at the lymphocytes, with the 2 different groups of cells that you have here, the T cells and the B cells are going to be responsible for the production of antibodies. So antibodies, touched on very quickly in our last conversation, but they are going to be responsible for alerting your body that a foreign invader is there. Like I said, they can pull off those carbohydrate flags on the surface of the cell, hang on to them, and as they circulate through the body, It can alert other cells that this is what the foreign invader looks like, this is what you're looking for. And then those antibodies will stay in the body and they are housed within the body so that in the future, if you come in contact with it again, those antibodies are already made in place and you don't have to rebuild them. You can just immediately release them and signal that this invader is in the body. The T lymphocytes, they are going to deal with your what's called your cell-mediated immunity. So when you come in contact with a foreign invader, so bacteria gets into your system, the T cells are going to find it and they are going to deal with that foreign invader. And I want you to jump to the next slide because it talks about, jump to the types of T cells. So you have different categories of T cells. I already mentioned subcategories when we talk about the white blood cells, but you have three different categories. You have the helper T cells, the killer T cells, and the memory T cells. We don't just want to immediately kill and wipe out these foreign invaders. If we can take the time to learn about them, that makes us more efficient in dealing with them in the future. So the helper T cells, they actually have this product that they can release into the body. It's made out of proteins. And that is going to alert the killer T cells that they're going to have a job to do very shortly. So once that foreign invader is recognized, these helper T cells secrete or release this protein, and now that's going to be a signal to the killer T cells that something is there and they're going to need to start to go to work. It's kind of like a PA system in the building. You can make an announcement and alert everybody in the building of the message all at the same time. The killer T cells are exactly what they sound like. So once the foreign invader has been identified and we've learned about it, the last step is going to be for destruction, and that's where the killer T cells come in. They will grab onto the foreign invader, they will not let it go until it's destroyed. And the one thing that you need to understand about a virus, I told you earlier, it docks with the host cell, and when that happens, if we can get a killer T cell or if we can get an antibody to bind onto that virus before it gets to the host cell, it makes it too big and it can't get to the host cell that it's trying to invade and be able to inject its genetic material into that cell. So the killer T cells can bind to it, the antibodies can bind to it, and they prevent that virus from being able to get to the host cell that it's targeting. The last group is going to be the memory T cells. The memory T cells are going to be those ones, that group of cells that is going to remember everything that we've learned about a foreign invader. So once that cell has gotten in and we've learned about it, we know what it looks like, we know how to destroy it. All of that information is going to be housed within those memory T cells so that, again, next time we see it or we encounter it, we have the ability to effectively get the right cells to the right place to deal with it and get rid of it. Skip down to the last slide that has the picture of monocytes on it. So monocytes, and I want to clarify here, they are the largest in size, they are not the largest in number. So monocytes are the largest cells. They go through a transition, so they start out as monocytes, and as they grow and develop, they will eventually transition into a type of cell that's called a macrophage, a large eater. And basically what these monocytes are going to do is they are going to go around and find things that are foreign, and again, they are going to ingest them, and they're going to eat them, destroy them, and they will keep eating as long as they can find cells to eat. So it sounds a lot like the neutrophil. But with this particular cell, it will continue to eat until one of two things happens. Number one, can't find anything else to eat, it's eliminated everything that's foreign, or it will eat until it self-destructs. So it will actually eat until it ruptures and breaks open. Now when it gets to that point, all of the contents, all of the material that it has ingested, then gets put back into the body. So if that happens internally, deep internally, you really don't notice that. But if it happens at the surface, that is what you guys would call pus. So that white material usually has a very distinct smell if there's a lot of it. That is the remnants of all of these macrophages rupturing and breaking open, and that's telling you that you have a high amount of foreign invaders or infection going on in the body if the number of macrophages that are rupturing because they are just eating to the point of self-destruction. not a good sign. So if you ever had zits and you had whiteheads and things like that, that's what was coming to the surface, was the contents of those materials being regurgitated, so to speak. Now, I mentioned earlier, I don't expect you guys to know numbers as far as how many microliters there are within a drop of blood. All I want you to know is basically high, medium, and low. So when we're looking at the number of white blood cells that you should have in the body, when we're talking about just the number of white blood cells, if you have anything that is less than 4,000, that is going to be considered a low range. If you are between 4,000 and 10,000, that's considered to be in the normal range. And I will tell you right now, if I asked you guys as an assignment, and I'm not, but if I asked you guys to go out and find 10 different sources of the range of white blood cells in the body, you would probably get 10 different answers. So some places will put that 11,000. The numbers are going to vary. This is an approximation. So less than 4,000, that's considered to be low. Or between that 4 and 10 range, that's considered to be where you want to be, or that's on point. And once you start to get above 10, that's considered to be kind of a red flag that something's going on, that your body's having to produce these extra white blood cells for. The last one, and I just wanted to introduce this very quickly because you guys are going to do this as an activity when we come back face to face, but it's a normal blood smear compared to that is a leukemia patient. And you can see on the left, red blood cells highly outnumber the white blood cells. You've got some platelets going on in there, but you can see that comparison. When you look at the leukemia slide, you'll notice that the number of white blood cells has vastly increased. The other thing, and this slide doesn't do a great job of showing it, but you'll notice it when you look at the actual blood smears. The red blood cells actually become very faint. So where they have a good color to them in a normal blood smear, you can really pick up on that, the coloration of them. When you do a leukemia one, when you look at that, they're very, very light pink, and they're very difficult to see underneath the slide. But we'll talk more about that when we actually get to do that activity in class. So just looking at the immunity side of things, and like so many other topics that we have, pretty much every topic that we have, we could spend an entire semester on this alone and still not cover everything. So just kind of wanted to give you the highlights and the basic information so that as we move forward and in other conversations and classes, as you guys start to hear more and more about this, you'll at least have that foundation piece in place. Your assignment is going to be posted in Blackboard, so go ahead and look to Blackboard for that.